Okay, everybody, we're working through the diploma prep material. This is the chapter on trigonometry. And what I got to do here is I'm going to fill in this chart, okay, identifying the different pieces of these trigonometric functions here. So the first thing I got to do for each of these is identify the amplitude. Now, the amplitude is related to the vertical stretch, which is going to be the coefficient at the beginning in front of the trig function here. However, we need to emphasize right here that the amplitude is not negative. That negative implies a vertical reflection, but that is not the vertical stretch. This was not vertically stretched by a factor of -3. It's only been vertically stretched by a factor of 3. So the amplitude here is +3, the amplitude here is +1. Do not include the negatives with the amplitude. Okay, the next thing we're going to look at here is the period. It is a mistake to think that the period here is 1/2 and that the period here is 2. Those are the B values. Those are giving us information about the horizontal stretch, but that is not giving us the period. Remember the formula here, okay? The period, or I should say it like this, the B value is 2 pi divided by the period, okay? Or if you will, it's 360 degrees divided by the period. Which means, likewise, that you could write, and I'll do this over here then, that the period will equal 2 pi over b, okay, or it will equal 360 degrees over b. So now let's come back to this right here. The period in this case right here, well, the b value here is 1/2, okay. So, and notice that in this case we're in degrees, okay, because I can see that the horizontal phase shift is in degrees. So what this means is the period has got to be 360. Okay, that's not a very nice one. This has got to be 360 degrees divided by 1/2 to get you 720 degrees. Now I'll just erase that and write that in here. Okay, 720 degrees. Over here, the B value is 2. Okay, and so I can see that I'm in radians in this case right here. So this is going to end up being 2 pi divided by 2. And again, I'll erase that and just simplify it. The answer is pi. Next, horizontal phase shift. Okay, that's essentially the horizontal translation. So I come to my equation here, and notice in this case that I've got the x here plus 30, which implies the translation 30 degrees to the left. And so that's what we'll say here, 30 degrees left. For this next one, that is not so straightforward, because in this case I can see, like in this first one, I can see that the stretch has been factored away from the translation, but here it's been multiplied through. So in order for me to get this correct, I have to take and divide out that stretch. So this has to be 2 times x minus pi over 3. Now I have a much cleaner view of what the horizontal translation is, or the horizontal phase shift. That has been pi over 3 to the right. Okay. The last thing that we're going to look, or sorry, the second last thing we're going to look at here is the vertical displacement, and that is just your vertical translation, and that's actually pretty easy to see on this one here. This has been moved 2 down, okay, because the -2, this has been moved 2 up. So this will be a vertical translation of 2 down. This will be 2 up. Now, the mapping, and remember, the mapping is just a description of or basically writing out what this is saying, okay? So, our mapping here is going to be 2 times the x-coordinate minus 30 degrees, comma, now there's not a lot of room here, -3y minus 2. There's the point. Here, this is going to end up being 1/2 x plus pi over 3, comma, -y plus 2. That's the mapping that we're looking for.